Welcome back to CIA Declassified. The era is the mid 1990s. The Cold War has thawed, but the proliferation of nuclear materials has become the new global nightmare. Rogue states and hidden facilities are the priority. Imagine the heavily guarded cooling ponds of a suspected nuclear reactor. Traditional divers would be spotted. Standard submersibles are too loud and too obvious. The agency needed something that belonged in the water, something that wouldn't draw a second glance from a sentry or a sonar operator. In the high-tech workshops of the Directorate of Science and Technology, engineers were obsessed with biomimicry. This wasn't just about building a robot, it was about stealing nature's own designs to bypass the most sophisticated security on Earth. This was the era of Charlie Robo-Fish. How did this mechanical marvel get its name? The name Charlie was a playful internal moniker given by the project leads at the CIA's Office of Advanced Technologies. While many CIA projects use random computer-generated cryptonyms, this invention was named Charlie as a nod to channel catfish, the specific species the robot was designed to imitate. The Robo-Fish designation was the functional title used in internal budgetary and design documents to distinguish it from the agency's avian-based infectious agent biomimicry programs. Charlie Robo-Fish was the agency's deep dive into autonomous aquatic intelligence. Charlie was an unmanned underwater vehicle, a UUV, designed to look, swim, and behave exactly like a common catfish. A quote from a declassified CIA briefing. Charlie was a breakthrough in biomimicry. By replicating the oscillating tail movement of a fish, we achieved a level of stealth that traditional propellers could never match. End quote. Records show that Charlie was controlled by a line-of-sight radio handset, though later iterations were designed for semi-autonomous navigation. Documentation confirms that the robot's hull contained a pressure hull and a ballast system, allowing it to dive and surface like a real fish. The invention utilized a wagging tail propulsion system driven by a miniature internal motor, which minimized the acoustic signature that usually alerts sonar. A quote from a declassified DST engineer's log. The challenge wasn't just making it move, it was making it move inefficiently. Real fish don't move with the steady hum of a drone. They pulse, end quote. Logs indicate that Charlie was equipped with a water intake system designed to siphon samples to detect isotopic traces of plutonium or enriched uranium. Technical files reveal the robot's skin was made of silicone-based polymer that felt like fish skin to prevent detection by touch or physical inspection. Records prove that Charlie was tested in the Potomac River to see if it could navigate strong currents without losing its natural appearance. The program integrated a micro camera in the head of the fish, allowing for close-up photography of underwater intake pipes and structural foundations. Documentation confirms that the robot was 61 centimeters long, making it a perfect match for a mature catfish found in most northern hemisphere freshwater bodies. Internal ledgers confirm the agency spent hundreds of thousands of dollars to ensure the whisker sensors on the robot actually functioned as radio antennas. Records indicate that the project was part of a broader unmanned biomimetic systems initiative that included robotic dragonflies and even mechanical birds. The initiative utilized lithium battery technology that was cutting edge for the mid-90s, allowing for hours of low-speed observation. Records show that Charlie had a self-destruct mechanism that would dissolve its electronic components in caustic acid if it were captured. Internal files reveal the robot utilized a navigation gyroscope that allowed it to remain level even in turbulent water stirred by large cooling pumps. Documentation shows that the program produced 3 different versions of Charlie, each optimized for different water temperatures and salt densities. Logs prove that Charlie successfully bypassed a standard military-grade sonar net during a demonstration for the Joint Chiefs of Staff. Technical manuals confirm the use of acoustic modems that allowed Charlie to talk to a nearby submerged buoy to offload data without surfacing. The agency recruited marine biologists to consult on the behavioral loop programming, ensuring the robot didn't swim in patterns that appeared artificial. The Charlie robot featured a buoyancy control system that utilized compressed air tanks to mimic the swim bladder found in biological fish. The agency's Office of Research and Development developed a specialized oil-based lubricant for Charlie's internal gears to prevent water contamination from leaking mechanical fluids. Official schematics confirm that the robot's oscillating movement was achieved through a complex series of pulleys and tension wires that flex the tail from side to side. Internal project notes reveal that the team had to paint the exterior of the silicone skin by hand to replicate the specific molting of catfish found in the Middle East. Records show that Charlie underwent over 500 hours of hydrodynamic stress testing to ensure the tail would not snap under the pressure of deep water siphoning. The agency designed a release and recovery cradle that could be mounted to the bottom of a nondescript fishing boat to deploy Charlie in plain sight. Historical logs prove that Charlie's electronic brain used a 16-bit processor, which was powerful enough at the time to manage both propulsion and sensor data. Documentation confirms that Charlie was the first CIA robot to successfully employ closed-loop depth sensing, allowing it to stay within inches of the riverbed without crashing. Historical records confirm that the project used acoustic dampening gaskets between the internal motor and the silicon hull to prevent metal-on-metal vibrations from radiating into the water. Documentation reveals that Charlie utilized a variable speed tail actuator, allowing it to adjust its swimming tempo to match the current speed of the surrounding water body. Internal memos prove that the agency conducted cross-species validation by placing Charlie in a tank with live catfish to see if he triggered a flight response in the real animals. Logs indicate the propulsion system was so efficient that Charlie could maintain a station-keeping position against a 2-knot current for over 90 minutes. Records show that the nose cone of the robot contained a highly sensitive isotopic sieve capable of trapping single atoms of heavy metals for later analysis. Technical manuals confirm that Charlie's internal radio receiver was shielded with a Faraday cage to prevent its own motor from interfering with the command signal. Documentation proves that the robot was weighted with lead distributed along its spine to ensure it would not roll over during sharp turns. Internal reports confirm that Charlie participated in a joint exercise with the Office of Signals Intelligence to test if underwater low-frequency signals could be used for over-the-horizon control. A quote from a declassified technical memo: Charlie represents the apex of DSTS's effort to hide complex telemetry within the mundane forms of the natural world. End quote. Records indicate that the project team had to overcome buoyancy drag caused by the weight of the radiation sensing equipment tucked inside the fish's belly. Internal files confirm that the radio handset used to pilot Charlie was disguised inside a standard tackle box to avoid suspicion during field test. Historical data confirms that the program successfully reduced the robot's acoustic output to levels below that of a standard electric trolling motor. The agency tested a saltwater variant of Charlie that used corrosive-resistant titanium components for potential missions in the Mediterranean. Records prove that the tail fin was the most replaced part during the testing phase due to the high torque demands of the wagging motor. Internal reports reveal the project leads nicknamed the lab where Charlie was built the fish tank. Documentation shows that the agency successfully miniaturized the radiation isopleth sensors specifically for this project, a feat that had never been achieved before 1993. Logs confirmed that Charlie's eyes were actually high-resolution lenses that could transmit images back to the handler in real time. Project records indicate that the robot was designed to be neutral buoyant, meaning it could hover in the water column without using any power. The agency developed a rapid exfiltration protocol for Charlie involving a high-speed retrieval net that could snag the robot at 10 knots. Technical files confirm that the robot's whiskers were made of flexible nitinol alloy that could bend without breaking. Historical memos prove the project was kept so secret that even the agency's internal security teams were not told what was in the transport crates. And the declassified documents for Charlie Robo-Fish, the heaviest redactions appear in the field deployment log, Operation Aquarius. According to researchers at the National Security Archive, the most censored pages deal with the recovery phase, how the agency got their fish back after a mission. In the darkest corners of the internet, theorists look at those blacked out pages and see the poison pill protocol. Some speculate that Charlie wasn't just for taking samples. The theory suggests the robot carried micro-explosives designed to be sucked into a reactor's cooling intake, causing a catastrophic but seemingly accidental failure. They point to several unexplained cooling pump failures in foreign reactors during the late 90s as proof that Charlie was a silent assassin. There is a strange, persistent whisper that the redactions hide the mating signal. This theory posits that Charlie was designed to be a lead fish. Speculators believe the agency used pheromone-mimicking chemicals to lure real schools of fish to surround the robot, creating a biological shield that made it 100% invisible to even the most advanced sonar. They claim the redactions hide the chemical formula for this fish magnet. Some naval history buffs suggest the redactions hide a deep-sea cable tap. The theory posits that Charlie was dropped into the ocean to find undersea fiber optic cables and bite into them to install a shunt. They believe the black ink hides the coordinates of where the agency is still listening to the world's internet traffic from the bottom of the sea. A more recent high-tech conspiracy has bubbled up from the depths of the bionics community. Some claim that the redacted Operation Aquarius files actually describe the deployment of Charlie 2, a robot that wasn't purely mechanical. The theory suggests the agency successfully merged robotic components with a genetically modified living catfish brain to create a true cyborg. They believe the blacked out sections hide the ethical concerns and the eventually horrific results when the living drone began to develop its own instincts and refused to return to its handlers. Was Charlie Robo-Fish a success? Tactically, it was a technical masterpiece. It successfully proved that the agency could build a machine that moves so naturally it could fool both humans and electronic sensors. Strategically, it was a stealth enabler. The invention was a success because it opened up a new avenue of approach for the Directorate of Science and Technology. The success of Charlie is found in its proof of concept. It successfully bridged the gap between biology and machines. The agency successfully proved that nature's designs are the ultimate blueprint for stealth. However, the program's success was also its limitation. It successfully gathered data, but the range of radio control meant the handler had to be dangerously close to the target area. It successfully paved the way for the multi-million-dollar UUV programs we see today. The mission was a total success in terms of demonstrating acoustic invisibility. It successfully integrated micro-robotics with environmental sampling. Ultimately, it was a success because it allowed the agency to confirm the nuclear status of at least 2 hostile facilities without a single boot on the ground. The program successfully identified that the future of espionage was unmanned. It successfully turned the water from a barrier into a highway for intelligence. The project was an undeniable success in proving that biomimicry could solve the acoustic signature problems of traditional submersibles. It successfully delivered high-fidelity radiation data from denied access cooling ponds that were otherwise unreachable. Furthermore, the success of the project is written in the silence of its deployments. It successfully completed its objective without once being identified by hostile forces. This program successfully transformed the agency's approach to reconnaissance. By the time it was retired, it had successfully proven that low-tech disguises could hide high-tech sensors better than any armored drone. It was a success because it functioned flawlessly in environments where a human would have been killed or captured. In the final account, Charlie was a success because he taught the agency how to listen to the water itself. As far as technological and operational breakthroughs go, the mechanical deep resulted in breakthroughs that define modern underwater technology today, such as biomimetic propulsion. The oscillating tail technology developed for Charlie is now used in modern bioswimmer drones for hull inspections of Navy ships and bridge pylons. Microballast regulation. The ultra-small ballast tanks used to keep Charlie level are now integrated into modern oceanographic glider drones that monitor climate change for years at a time. Miniaturized isotopic sensors. The tech used to sniff the water for radiation is now the standard for portable environmental monitors used by the IAEA to verify treaty compliance. And silicone polymer stealth coatings. The skin developed for the Robo-Fish is the ancestor of the tile coatings used on the newest generation of stealth submarines. Charlie Robo-Fish reminds us that innovation often looks like something we've seen before. The mechanical deep proved that the most sophisticated technology can be hidden in plain sight, or rather, in plain water. The silicone catfish of the 90s has evolved into the swarming autonomous fleets of the present day, but the core principle of mimicking nature remains the ultimate goal. We are still living in the world shaped by these bionic observers. Every time an underwater drone navigates a complex environment, it carries the DNA of Charlie. The story of Charlie is a story of looking at a common catfish and seeing a revolutionary intelligence platform. The robot may be retired, but the water is more crowded with Robo-Fish than ever before. We must remember that the quietest ripples often carry the most weight. Through Charlie, the agency achieved a mastery of aquatic infiltration. The invention proved that sometimes the best way to get to the truth is to act like you're just looking for a meal. By mimicking the simple life of a fish, they secured the complex safety of a nation. The ripples Charlie left behind are still felt in every naval laboratory on the planet. It serves as a reminder that in the world of high-stakes secrets, the most effective disguise is the one that has been swimming there all along. In the silent, dark waters of the mechanical deep, the agency found a way to become part of the environment itself. This bionic legacy continues to haunt the coastal waters of our adversaries, a silent sentinel of a bygone era. Charlie proved that even the humblest creature can hold the key to global security. His story is a testament to the brilliance of the engineers who dared to look at a catfish and see a spy. Thanks for listening. Stay safe, and remember, watch the water. Join us next time as we examine Operation Banana. In the heat of the Dominican Republic, the agency attempted to plant the seeds of resistance, only to watch them wither. We'll uncover the facts behind Operation Banana, the failed attempt to establish a stay-behind agent network. It was a game of Cold War chaos, failed logistics, and the high-stakes failure that left an entire network in the cold. Join us next time for The Island in the Dark. In the meantime, I'll see you in the archives.